everyone, by the way, I am Roxanne A. Dum-ogan and I am 21 years old. I'm lived in Iba, Cabanglasan, Bukidnon. So, in this video, we will discuss about the glass and glass fracture. So, first, what is glass? Glass is an amorphous solid. The term is usually applied to inorganic solids and not to plastic or other organics. Glasses do not have crystalline eternal structure. So, here are the properties of glasses. Number 1. Glass is somewhat flexible. It tends to bend upon application of force. Number 2. Glass bends on the direction where force is applied, causing the opposite side to stretch. Number 3. Glass can withstand more bending rather than stretching, causing the opposite side to start breaking. So, what is glass fractures? So, glass fractures may be caused excessive exposure to heat or caused by impact of a blunt instrument of object or caused by projectile. So next is types of glass fracture. Number 1. Radial fracture. Radical cracks are fractures extending outward from the point of impact. Rim is an imperfection, non-homogeneous layers of flat glass. Number 2. Concentric fractures. Concentric cracks are fractures forming in approximately circular pattern around the point of impact. So, number 3. Conchoidal fracture is a smoothly curving fracture of line-grained materials which have no planar surfaces of internal weakness or planes of separation. So, fractures caused by blunt or instrument. Thorough examination of glass fractures caused by the impact of a blunt object instrument will reveal a pattern of radial and concentric fractures. So, fractures caused by projectiles. A small dense object as a bullet, pebble, or steel ball may impact upon a pane of glass with such a little force or at such a high speed that there is no bulging of the glass. So, the significance of determining the types of glass fractures. Number 1. Point of impact. Glass is at its maximum strength under compression but weak in tension. An impact on a pane of glass causes it to bulge. Number 2. Direction of impact. The impact of the bullet hitting inside will break away a crater on the opposite side of the glass. So, factors to be determined in glass fracture. So, letter A, point of impact. Next is the position of the shooter. Number 1, perpendicular shoot. So, exhibits an even distribution of chipping on the exit side of the glass. Number 2, angle from the right, heavy plaking or chipping on the left side of the glass. Number 3, angle from the left. So, heavy flaking on the right side of the glass. So, letter C, age of fracture. So, number 1, fresh fractures. Exhibit a regular pattern of radial concentric fractures. Old fractures. Number 2, old fractures. Presence of a short extension lines at the end of the radial fractures. So, what is here? Here is a protein filament that grows from follicles found in the dermis. Here is one of the defining characteristics of mammals. The human body, apart from ears of glabrous skin, is covered in follicles which produce the terminal and vine vellus hair. What can be determined from the human hair? Hair analysis is used to provide DNA evidence for criminal and paternity cases. For DNA testing, the root one hair is needed to analyze DNA and establish a person's genetic makeup. So next is the structural parts of the hair. Here, number 1, hair shaft is consisted of 3 layers, such as cuticle, cortex, and in certain cases, medulla. Number 2, flat and square. Shape cuticle cells are adhered tightly to the cortex cells proximally. Number 3, hair shaft pigmentation. Dark hair predominant. Hair shaft diameter and length vellus of 0.6 meter. The hair bulb. Each of the hair grows from its own individual follicles. The hair bulb is situated at the base of each hair follicle and contains young growing hair cells. These continually divide and push upwards, gradually hardening. So next is the inner aspect. So number 1, cuticle. The cuticle is your hair protective layer composed of overlapping cells like fish scales or root tiles but facing downward. A healthy cuticle is smooth and flat. This gives your hair shine and protects the inner layer from damage. Letter B, the outer aspect. So number 1, tip. Distal end portion of the ear. Number 2, shaft. The shaft, the part of a hair that you see, is made of cells that aren't living anymore. Each hair shaft is made up if 2 or 3 layers: the cuticle, the cortex, and sometimes the medulla. So the cuticle is the outermost layer. So number 3, root. Root is the portion that is embedded in the skin. So, what is the main purpose for examining a hair found in the crime scene? So, hair samples are one of the most important resources in the forensic analysis of crime scene, often providing valuable information that can help to lead to the identification if suspect or victim. So, what can you tell from hair analysis? Your hair absorbs chemical from the medications you take, the foods you eat, and environmental toxins. And this information stays in the hair shaft for several months. Hair analysis can reveal drug use habits, genetic diseases, heavy metal poisoning, and conditions. So, next is what is the purpose of hair examination? Number 1, to determine whether the hair is questioned, originated from an animal or human being, and comparison of questioned and known hair. Number 2, to ascertain whether 2 or more individuals could have come in contact or whether one more individuals could have in contact with an object. Next is what is ultraviolet examination. So this examination technique is based the fact that certain materials fluoresce because they absorb the wavelength of ultraviolet light, which causes an electronic transition in some of the molecule of the material. What is the purpose of ultraviolet examination? So, ultraviolet or UV light allows investigators and forensic researchers to examine, close, and recover evidence that could not have been previously detected. So, next is what is ultraviolet light examination? So, the examination of an object with ultraviolet radiation 500 nanometers emitted by a wood's lamp in the dark makes it opposite to distinguish adhesions, repented areas, and vanished layers due to the different fluorescent and reflection of the materials. Next is fiber. So what is fiber? Fiber analysis is a method of identifying and examining fibers used by law enforcement agencies around the world to procure evidence during an investigation. Fiber analysis is also used by law enforcement agencies to place suspects and the same if the crime. So, how are fibers used in forensic science? So, as discussed previously, fibers are considered a form of trace evidence that can be transferred from the clothing of a suspect to the clothing of a victim during the commission of crime. So, next is how are fibers used to solve crimes? So by matching fibers at the crime scene of a crime to items belonging to a suspect, investigators are able to place individuals at a crime scene. So, what are the three types of fibers of forensics? So, first is the fibers come in three different types, such as natural fibers, which come from plants, and animal manufactured fibers, which are formed and natural materials that are created from natural materials, and synthetic fibers, which are from completely man-made materials.
My name is Shashank, and in today's video we will talk about the fibers. So, in this following video, the following content we will see. First, what is fiber, then different types of fibers, the significance of fibers as trace evidence, methods of collecting fiber samples from the crime scene, different methods for the analysis of fiber. First of all, fibers are thread-like structures from fabric and other materials which are easily identifiable under a microscope. Or we can say, smallest unit of a textile material that has a length many times greater than its diameter. Its source can be determined by comparing it with fiber of a controlled sample. Just as hair left at a crime scene can serve as identification, the same logic can reasonably be extended to the fibers that compose our fabrics and garments. Then, polymer. The word polymer is coined from two Greek words, that is poly and mer. Poly means many and mer means unit or part. The term polymer is defined as very large molecules having high molecular mass. These are also referred to as macromolecules, which are formed by joining of repeating structural units on a larger scale. The repeating structural units are derived from some simple and reactive molecules known as monomers, linked to each other by covalent bond. This process of formation of polymers from respective monomers is called polymerization. Then we can classify polymers on the basis of source. First of all, natural polymers. Its examples are cellulose, starch and resin. Then semi-synthetic polymers. Example, cellulose derivatives. Then synthetic polymers, that is synthetic fibers. Classification of fibers. Fibers are classified into two: natural fibers and man-made fibers. Man-made fibers are also called artificial fibers. Natural fibers are divided into three, that is animal fibers, plant fibers and mineral fibers. Animal fibers include silk, wool, hair of animal, etc. Plant fiber includes cotton, leaf and etc. Then mineral fibers include asbestos. Then artificial fiber is classified into two, that is synthetic polymer and natural polymer. Synthetic polymer includes polyester, nylon, dacron, polyvinyl derivatives, etc. Then natural polymers, it includes rayon, cellulose ester, etc. Then natural fibers. The oldest fibers known to us are the natural fibers. Since these are made up of cells, they have better ability to absorb moisture and are thus considered to be very comfortable. So, the clothing that directly touches our skin is mostly made up of natural fibers. Natural fibers are further divided into two categories, that is from plant source and animal source. Fibers from plant source, that is cotton, jute and linen. Cotton fibers are commonly used in textile market. The type of cotton fiber, length, the degree of twist contributes to the diversity of these fibers. The processing techniques and color application also influence the value of cotton fiber identification. Then fibers from animal source. Animal fibers, which are mostly used in textile materials, is wool, and the most common wool fibers come from sheep. The end use of sheep's wool indicates the fineness of woolen fibers. The finer wool fibers are used in making clothing, while coarser wool fibers are used to make carpets. Thus, the diameter of wool fibers holds importance in the analysis of the fiber from the crime scene. Wool from Angora goat, camel are also found. Other example for animal fibers is silk. Here you can see the example of different types of fibers, that is natural fibers and man-made fibers. Natural fibers include cotton, wood fiber, cotton fiber and wool fiber. Then man-made fiber is shown, that is dacron, nylon, nylon fiber, polyester fiber. Then we will look forward to man-made fibers. They are also called artificial fibers. These fibers are alternative to the natural fibers. More than 50% of fibers are man-made. The most common example of man-made fibers are nylon, dacron, followed by acrylic and many more. These are mostly used in garments, foam padding and soundproofing. Today, such fibers are marketed under hundreds of different trade names. To reduce confusion, there are generic or that is family names for the grouping of all manufactured fibers. For example, acetate, acrylic, rayon, nylon, polyester, and many more. Significance of fibers as trace evidence. They are easily transferred from the clothing of a suspect to that of the victim. They are capable of multiple transfers. For example, from carpet or bed to the suspect's clothing. These transfers can be direct or indirect. By direct transfers, we mean that the fiber is transferred directly from a fabric onto a victim's body. While by indirect transfer, we mean that the already transferred fibers on the clothing of a suspect are transferred to a victim's body. Fibers vary according to their end use. Another important consideration is the time delay between the actual physical contact and the collection of clothing items from the suspect or victim. If the victim is immobile, very little fiber loss will be there, whereas the suspect's clothing will lose the transferred fibers quickly. The possibility of the finding transferred fibers on the clothing of the suspect a day after the actual contact had been made will be very remote depending upon the use and handling of the clothing. Then, collection and packaging. Photographs of all the evidence should be taken prior to collecting them. Here the procedure for the collection is SMS procedure used for the hair. Collected with hand picking methods, where hand should be covered with gloves. Collected with the help of plastic tweezers or forceps. Other methods for collection are tap lifting method and vacuuming method. They all are packed in the paper bag or druggist fold paper. Then the analysis of fibers. Here the three steps are used, that is primary examination, microscopic examination and chemical examination. Here you can see the analytical processing chart for the fiber analysis. Then primary examination. Here the following characteristics are seen, that is color of the fiber, location of the fiber and birefringence. Then microscopic examination. First of all, fiber diameter. The fibers vary in size from 10 to 50 micrometers. The softer materials will have smallest fibers, while the most durable materials will have the largest fibers. Also, for example, the finer woolen fibers are used for making clothing, while the coarser ones for using carpets. So again, the size of the fibers can tell its origin. Then, fiber cross section. Basically, it is the cross section of the fiber that varies according to the type of the fiber. The natural fiber have their origin from plants and animals and thus look rough at the edges. This feature on the examination can actually reveal whether the fiber is natural or man-made. Here, microtome is used to make cross-section. Here we can see the microscopic view of various cross-section of fibers, that is round, trilobal, dumbbell shape, flat and multi-lobed. Then atomic force microscopy. Atomic force microscopy is a method which is carried out using an atomic force microscope. It is an instrument to analyze and characterize samples at the microscopic level. The instrument will allow an analyst to look at the surface characteristics with very accurate resolution ranging from 100 micrometers to even less than 1 micrometer. Then other microscopes which used for fiber examination are scanning electron microscope, polarized light microscope and comparison microscope. Other methods used for examination are Raman spectroscopy, IR spectroscopy and UV visible spectroscopy. In the following photo, we can see a photomicrograph of a nylon fiber displaying interference colors when observed between the crossed polars of a polarizing microscope. Then, chemical examination. The chemical analysis will involve the extraction of the dye from fiber sample and then characterizing and identifying its chemical structure. It is actually difficult to extract a dye from the fiber sample, as these samples are typically small, and it is also made sure by the textile dyers that the dye stays in the fiber. This method of dye analysis is a destructive method which leaves the fiber useless for further color examination. But still, since some fibers have similar colors, that chemical analysis becomes unnecessary. Other method is burning test. Thank you so much for watching the video, and for the more content and for the more material you can visit our website, that is www.thescihub.in. You can have the more material regarding this topic and others too. Thank you so much for watching.